Hello everyone, welcome to the Mercury Virtual. Hope you are doing good. In the yesterday's class, we have started with the main module, that is computer systems, a programmer's perspective. In the last class, we have studied what is C language, what is the syntax for C programming language, and we have also took the compilation system and other procedures. So let's take a quick recap of the last class, that is previous class, yesterday's class. In last class, we have discussed what is computer system. That consists of hardware and software. Hardware means the component that we can touch, and software means the program that we cannot touch. And we have also talked about what is C programming language, and we also use one simple program, that is hash include stdio.h int main printf hello world. So this prints the line that is hello world, and /n is used for next line option. Then we have also talked about what is information. Information is nothing but the combination of the bits or the bytes or the content or the context. So bits is a 0 and 1, and when we combine 8 bits, that forms a byte. So information is nothing but the bits as well as the text characters. And most systems represent text character using the ASCII standard. As I told you, ASCII full form is American Standard Code for Information Interchange. In the same way, we have written the C programming language code. That programming code is also converted into the ASCII code, that is American Standard Code for Information Interchange. We have converted the hello.c program that we have included in last slide, in last page, that is hash include stdio.h. So hash have a different ASCII code. In the same way, I has a different ASCII code, S has a different ASCII code. So the meaning is that information is nothing but the combination of the bits as well as the content. Content includes the ASCII code. So if a number, if a digit is represented by a ASCII code, so that is the content of the code. Like this one, hash have a ASCII code 35, 105, 110, 99, 108, 117, and there are so many ASCII codes, each and every individual, whether it may be escape character like /n, /n, space, everything have a ASCII character. This shows ASCII text representation of hello.c. Hello.c is my name of the program. Then we also talked about what is C language. C language is developed by Dennis Ritchie at Bell Laboratory. This is the ANSI standard, that is American National Standard Institute, rectified the ANSI C standard in 1989, and this combines with ISO, that is International Standard Organization. And we also discussed what are the features of the C language. It is closely tied with the Unix operating system. It is a small and a simple language. It was designed for a practical purpose. So these are the benefits or the features of the C language. Next, we have talked about what are the programs and how one program are translated by other program into different forms. So we have converted, or we have used the executable program files. So automatically when programs are written, they are written in a programming language, and they must be converted into the object code or the executable object code or the executable object files. This is a compilation system which we have studied yesterday. First of all, hello.c. This is the main program. This is converted into, first of all, hello.i. That is converted into the text with the use of preprocessor. Then hello.i is converted into the hello.s, that is assembly program, with the help of compiler. Then hello.s is converted into the hello.o with the help of assembler. And hello.o is a relocatable object program, that is a binary program. And that hello.o is converted into the simple hello, that is executable object program or executable object file. So these are the multiple steps which are used when we compile the program, when we compile the code of the C programming language. First of all, hello.c, then there are 4 phases, and then hello.c is converted into the hello part. These are the multiple parts, these are the multiple phases which is used in compilation system like preprocessor, compiler, assembler and the linker. Then we have talked about how it pays to understand how compilation system works. These are the important reasons why programmer need to understand how compilation system works. Means what is the benefit, why we are using the compilation system, what are the benefits or what are the advantages of compilation system. These are the multiple advantages. First of all, it optimizes program performance. Means it enhances the program performance. Then it helps to understand link time error. When there is any error at the time of linking, suppose at the time of linking of the source program, if there is any error, so that must be detected by the C language. That must be detected by the C programming language. So this is the main advantage why we are using the compilation system in C language. Then avoiding the security holes. There are multiple security holes, or there are multiple security issues or security issues that is available when we compile the program. So this is the responsibility of the compilation system or the compiler to avoid these security holes so that there is no security hole in the network and the internet server. Then we also talked about how processor reads and interprets instructions that is stored in the memory. These are the multiple ways that we have done or that we have studied yesterday. How a shell that is a command line interpreter that prints a prompt, waits for you to type a command line, then performs a command. So this is a command line interpreter which helps you to print a prompt and waits for you to write the command in this way. This is the prompt Unix. There is a hello world Unix. These are the multiple ways that we are using for writing the program. So shell is a command line interpreter that waits for you to write the command and then executes the command based on the information given by the user. Then we also talked about what is the hardware organization, what is the hardware implementation of a system. This is the hardware implementation of a system. This is the block diagram of hardware implementation of a system. This contains CPU, input-output bridge, main memory, USB controller, graphic adapter and disk controller. CPU is responsible for executing the programs. Input-output bridge is useful for connecting the memory with the CPU. Suppose I want to contact or I want to give the data to the memory unit, or I want to fetch the data from the memory unit. So that must be provided by the input-output bridge. And these are the USB controller like mouse, keyboard that is used for giving the input as well as for fetching the output. Then there is a graphic controller or graphic adapter that is used for displaying the output. Then there is a disk controller. Disk controller means where we can store the data. So these are the multiple options. So these are the multiple figures that is used when we are using the CPU and when we are using the hardware implementation of a program. Then we also talked about in detail what is buses, what is input-output devices, what is main memory, what is a processor that is CPU, what are the multiple steps when we execute the program, then how to run the hello program, that is a basic program. These are the how we can read the hello command from the keyboard. This is user can type with the help of keyboard. From this line that must be goes to the CPU from the main memory. So in this case input output is acts like a mediator between the CPU, main memory and the USB controller. In the same way, this is another device where we can store the executable file into the main memory. This is how we can store the executable file. Main memory, disk controller. This also again acts as a mediator between the main memory and the disk controller. Then how to write the output string from memory to the display. Here how we can write the output string. These are the multiple devices, these are the multiple lines that we are using when we display or when we write the output to the memory or output to the displaying device. Now till this point we have covered yesterday. Now next topic is caches method. First of all, understand the concept. Cache is one type of memory. Cache is a type of memory, like there is a main memory, primary memory, secondary memory, register. In the same way, cache is also a memory. There is a requirement for the cache memory. For example, first of all, whenever we write any program that is loaded into the C language or the C programming language, that must be loaded whenever there is a copy to the main memory. So this line says, when a program is loaded, they are copied to the main memory. So whenever a program is loaded, they must be copied to the main memory so that it can be executed by the user or it can be executed by the program. And after CPU starts processing or the processor runs the program, instructions are copied from main memory to the processor. So it means, first of all, when the program is loaded, they must be copied to the main memory. And whenever the processor runs the program, then automatically the instruction or the program are loaded from the main memory to the processor. It means, first of all, copy to the main memory, then copy from main memory to the processor. So this takes lots of time in processing from one memory to another memory, from one place to the another place. So there is a provision, there is a facility that we use is the cache memory for this purpose. We use cache memory for displaying the output, for displaying the input, or for storing the data. So this says, from the programmer perspective, much of this copying means much of transferring from one place to another is overhead that slows down the real work of the program. Therefore, a major goal for system designers is to make these copy operations run as fast as possible. So this is the main goal, or this is the main ideal for system designer, to make these copies. These copy means this jumping from one place to another runs as fast as possible. So there is no lacking or there is no hindrance for the program. It runs smoothly. Because of physical laws, larger storage devices are slower than the smaller storage devices. Then in next paragraph, it is saying that there is a gap between the movement. When we move from one place to another, so there is some gap. So processor is not able to understand or is not able to handle what they are able to do. Even more trouble as semiconductor technology progresses over the year, this processor memory gap continues to increase. It is easier and cheaper to make processors run faster than it is to make main memory run faster. So it is mandatory for copying from one place to another, so that it must be copied to the another place. So there is to deal with the processor memory gap, system designers include smallest, faster storage devices. So to overcome this limitation from jumping to one process to another process that creates the memory gap, there is a deal, or there is a new process that is known as there is new memory that is known as the cache memory, or simple caches. You can call it as a cache or you can call it as a cache memory, that serves as a temporary staging areas for information that the processor is likely to need in the near future. Figure 8 shows the cache memory in a typical system. Now let's see what is figure 8. This is the figure 8. This is the cache memory. As I told you, cache memory lies between the CPU and the main memory. So this is the CPU, this is the main memory. So cache memory lies between CPU and main memory. This is the cache memory. All the bus interfaces, all the register files, all the ALU operations are performed by using the cache memory instead of the main memory. Because as you see, this is as much close to the CPU, but main memory is far as compared to the cache memory from the CPU. So this saves a lot of time, because if a data is coming from the cache memory, it takes less time as compared to when the data is coming from the main memory. So this is how cache memory lies, or cache memory behaves like a mediator between CPU and the main memory. This says a larger L2 cache with hundreds of thousands or millions of bytes is connected to the processor by a special bus. It might take 5 minutes longer for the process to access the L2 cache than the L1 cache, because L1 is the first cache that is lies in the cache memory, then L2, then L3, then L4, then L5 and L6. Newer and more powerful systems even have 3 levels of cache, means there are only 3 levels of cache, that is L1, L2 and the L3. The idea behind caching is that a system can get the both of a very large memory and very fast one by exploiting locality. Locality means to find anything in the memory. That can also be done with the help of the cache memory. This is one of the important line. The L1 and L2 caches are implemented with the hardware technology that is known as the static random access memory, that is SRAM. So these are the implementation, these are the hardware implementation of the L1 and the L2 caches. This is the concept of the cache memory that is required when there is a movement from one place to the another in the memory. Next is storage devices from the hierarchy. This topic is, as the name advises, storage devices from a hierarchy. There is a hierarchy for the memory. There is a hierarchy for the storage device. As memory is a hierarchy, so we can use the storage devices. There are multiple memories which forms a hierarchy, like primary memory, main memory, cache memory and secondary memory, as well as the registers. So this says this motion of inserting a smaller, faster storage device, example cache memory, between the processor and a larger slower device, that is main memory, turns out to be a general idea. In fact, the storage devices in every computer system are organized as a memory hierarchy. As I told you, there is a memory hierarchy, there is an arrangement of the memory that is done in the memory hierarchy. As we move from the top of the hierarchy to the bottom, the devices become slower, larger and less costly per byte. The register file occupies the top level in the hierarchy, which is also known as the level 0. So this is the hierarchy. First one is L0, that is registers. Then there is a L1, that is L1 cache, then L2 cache, L3 cache, L4 is the main memory. Then L5, that is the local disk or the secondary storage. Then there is a L6, that is remote secondary storage. So these are the hierarchy. This is the hierarchy for the memory. First of all, registers. This says CPU register holds words retrieved from the cache memory. So this is the cache memory that gives the registers a word so that it can be retrieved easily and processed as per the requirement of user. Next is L1 cache holds cache lines retrieved from the L2 cache. So this is the L2 cache, and L1 cache retrieves the lines or retrieves the whole lines that retrieve from L2 cache. This is going from bottom to the top, or from up or downward to upward. Then L3 cache holds cache line retrieved from the main memory. L2 cache holds cache line retrieved from the L3 cache. In the same way, main memory holds disk blocks retrieved from local disk, and the local disk holds file retrieved from disk on remote network device. So L3 dependent on the main memory, L2 dependent on the L3 and L1 dependent on the L2. This is smaller, faster and costlier, larger, slower and cheaper. When we going from upward to downward, they are larger memory, slower memory and the cheaper memory. And we are going from bottom to the top or downward to bottom, they are smaller memory, faster memory and the costlier memory. Next is, this says the main idea of a memory hierarchy is that storage at one level serves as a cache for storage at the next lower level. As I told you, the lower bottom or the hierarchy or the memory is dependent on the bottom hierarchy or is dependent on the downward hierarchy or downward memory. So this says the storage at one level serves as a cache for storage at the next lower level. Therefore, the register file is a cache for L1 cache. Caches L1 and L2 are caches for L2 and L3. So one line down is required for every memory. Next is your operating system. So in 6th topic we have covered what is memory hierarchy. First of all, there is a registers, then L1 cache, L2 cache, L3 cache, main memory, local disk and the remote secondary storage. Now next topic is operating system. This is one of the easiest topic in this chapter, operating system. As I told you in the previous classes, operating system. So what is operating system? It is nothing but a mediator between user and the hardware. Or can I say, or if I say, operating system is a system software that acts as a mediator or that acts as an intermediate between user and the hardware. So whenever user wants to interact with the hardware, user must use the operating system. So operating system lies a gap between the user and the hardware. This says the operating system has two primary functions: to protect the hardware from misuse by runaway applications, to provide applications with simple and uniform mechanisms for manipulating complicated and often widely different low-level hardware devices. So these are the main two targets, or these are the main two purposes for operating system in any programming language. First one, it protects the hardware. Second, it provides the application with simple environment so that users can access the environment or users can access the data. Users can easily write the code, write the program in the application. This is based on our hello example. When the shell is a command line interpreter. So when the shell loaded and runs, this is not ran, this is run the hello program. And when the hello program printed its message, neither program accessed the keyboard, display, disk or main memory directly. Rather, they relied on the services provided by the operating system. This means that the programs never communicate with each other directly, but they relied or they dependent on the operating system that provides the intermediate between user and the hardware. This is the layered overview of the computer system. This is the software, this is the hardware. As I told you, operating system lies between the user and the hardware. This is the user program, that is application program, and the hardware is processor, main memory, input devices. And operating system lies in between user and the hardware, that is between application program and hardware, that is processor, main memory and input output device. Next figure is abstractions provided by the operating system. This shows three parts, that is processes, virtual memory and the file. And these three topics we will cover in the later pages or in the later slides. There are three parts. One is processes, then virtual memory, then files. Now, let's see what is processes. A process is nothing but a program in execution. For example, if I am doing something, that is a process. So if I am doing any task that is in between the task, that is known as the process. In terms of operating system, if the operating system is dealing or if the operating system is performing any task, that is known as the process. This is when the program such as Hello runs on a modern system, the operating system provides the illusion that the program is the only one running on the system. So process is the only one running in the system. It depends on the operating system, what type of operating system you are using. The program appears to have exclusive use of both the processor, main memory and input-output devices. So this says the program can use of hardware, software, processor, main memory as well as the input-output devices. This says a process is the operating system abstraction for running the program. So whenever we have requirement for running the program, we need an abstraction that is known as the process. Multiple processes can run concurrently. Concurrently means along with side by side, or at the same time more than one program or more than one process are executed. This says multiple processes can run concurrently on the same system, and each process appears to have exclusive use of the hardware. Means whenever there are multiple processes, they are used or they are running concurrently one by one by getting the memory, by getting the resources from the operating system. This says the operating system performs this interleaving with the mechanism known as the context switching. So context switching is a technique that operating system uses whenever there are multiple processes and all the processes need the resources from the operating system. For example, if there are 4 processes in an operating system, so there must be a provision for switching from one part to the another, so that first of all one process will execute it, then another process will execute it, and then other process, and so on. So if there are more than one process and there is only one operating system, as every system has a one operating system, so there must be a need from switching from one content or from switching from one part to the another part, and that switching technique is known as the context switching. So context switching is nothing but the concept that we use when there are multiple processes and when we are moving or when we are transferring from one process to another, so that every process can get the operating system resources. That concept is known as the context switching. So I think it's clear. Context switching. Context switching is nothing but allotment of resources of the operating system. Then next line says the operating system keeps tracks of all the state information that the process needs in order to run. This state, which is known as the context, include information such as current value of the PC, register file, and the content of the main memory. At any point, a uniprocessor system can only execute the code for a single process. Next line says there are 2 concurrent processes in our example, that is shell process and the hello process. This is the same example which I told you yesterday. So this is the same example which is continuing. This says there are 2 concurrent processes in our example, that is shell process and the hello process. Initially, the shell process is running alone, waiting for the input on the command line. As I told you, shell is a command line interpreter which uses the command, which runs the command based on the scenarios or based on the input given by the user. When we ask it to run the hello program, the shell carries out our request by invoking a special function known as the system call that controls to the operating system. This paragraph says there are two processes. One is shell, one is hello program. First of all, shell will invoke, that is invoked by using a function that is known as the system call. Then a new process will come that is known as the hello process that passes the control to the new hello process. After hello terminates, the operating system restores the context of the shell process and passes control back to it, where it waits for the next command line input. So this paragraph says, first of all, the control is given to the shell, then shell gives the control to the hello program, and then hello program will be executed, and when it stores the or it's finished the execution, the control goes back to the shell program and waits for the another requirement or another need or the another input that is given by the user. So these are the multiple processes that are used by the operating system. Next is your thread. Thread is nothing but when we are using the multiple processes, that must be denoted by the thread. This says threads are an increasing important programming model because of the requirement for concurrency in network server. Because it is easier to share data between multiple threads than between multiple processes. Because threads are typically more efficient than the processes. So it is better to use threads. Thread is nothing but a process. So it is better to use threads than the processes. This says in modern system, a process can actually consist of multiple execution units that is known as the threads. So thread is nothing but a process that contains multiple execution. For example, if a process P1 contains or has 4 executions or 4 parts of execution, then that execution is known as the thread, or that multiple executions are known as the threads. Next says multi-threading is also one way to make programs run faster than when multiple processes are available. So it is able to use the multiple threads, or it is good to use the multiple threads when there are multiple processes in the operating system. Then next concept of operating system is virtual memory. First of all, we discussed what is processes, then we have discussed what is threads. Now what is a virtual memory? Virtual memory is nothing but the add-on memory that is used in access to the main memory. Suppose my requirement is to store 1024 KB data into the memory, but my memory capacity is only 1000 KB of data. So that 24 data which is in access, that must be going or that must be stored into the virtual memory. So virtual memory provides an illusion, provides a method that stores the data when the data is not fitted into the main memory. Right. So virtual memory acts as a enhancement or extra on of the main memory. This says virtual memory is an abstraction that provides each process with the illusion that it has exclusive use of the main memory. Each process has a same uniform view of memory, which is known as the virtual address space. The virtual address space of Linux process is shown in figure 13. This is a virtual memory, kernel virtual memory, user stack. These are the virtual memory parts: printf function, real-time if, read-write data, read-only code and data. This is the virtual memory, how we can use the virtual memory in the system. So simple concept is that whenever there is a requirement for the memory and main memory is not sufficient to store the data, then we use the virtual memory. Then there is a concept files. Next concept of operating system is files. A file is a sequence of bytes, nothing more and nothing less. So file is nothing but a collection of records or is a collection of bytes. where the data will be stored. Every input-output device, including disk, keyboard, display, and even network, is modeled as a file. So whenever we talked about the file in the operating system, it may include input-output devices, disk, keyboard, display, and even network, that is known as the file. Next line says, all input and output in the system is performed by reading and writing files using a small set of system codes known as the Unix input-output. So whenever we have to send the data or whenever we have to retrieve the data, that must be retrieved or sent with the help of multiple input-output devices, that is known as the Unix input-output. This simple and elegant notion of a file is nonetheless very powerful because it provides application with a uniform view of all the varied input-output devices that must be contained in the system. So these are the files where we can store the data. Next is system communicate with other system using networks. But before that, I suggest you to please read out the pages within 5 minutes, and if you have any doubt, then please text the doubt with the help of the chat. So please read the data or please read the text, read the file, read the pages till 7 point, means from 5 to 7. If you have any doubts, then please clear immediately, and then I move forward to the 8th part. So this is not a break, this is a time for your reading purpose. So please read the topics from 6th to the 8th or from 5th to the 7th. 5th is cache memory, then operating system, and then process, kernel, and so on. So please read it and tell me the doubts within 5 minutes. We have to read it. So let's take a break of 5 to 10 minutes and then come back and then starting with topic number 8, that is system communicate with other system using networks. So let's take a break of 5 to 10 minutes. Now let's start with topic number 8, that is systems communicate with other systems using network. As the name advises, how one system communicates with another system using the network. As I told you, network is nothing but a collection of computers, or network is nothing but when we combine more than one computer, that is known as network. This says system communicate with other systems with the help of the network. This is up to this point in our tour of systems, we have treated a system as an isolated system, means as a single system that is a collection of hardware and a software. In practice, in general, modern computer systems are often linked to the other system by using the network. Means whenever we have to combine, we have to connect one system to the another system, that is done by the network. From the point of view of an individual system, the network can be viewed as just another input-output device, as shown in figure 14. When the system copies a sequence of bytes from main memory to the network adapter, the data flows across the network to another machine instead of, say, to a local disk drive. Similarly, the system can read data sent from other machines and copy this data into the main memory. So this paragraph says how one system or how one computer communicate with another system with the help of the network, with the help of the input-output device, with the help of the main memory. With the advent of global networks such as internet, copying information from one machine to another has become one of the most important uses of the computer system. Suppose I want to copy or I want to give the command from one computer to the another computer. Suppose I want to take a printout. I have to give command, but printer is not attached to my system. So I have to give command. If the printer is attached, if the printer is shared, then it must be converted or it gives the output into the hard copy. So that is done by using the network. Returning to our hello example, that is the first example. We could use the familiar telnet application to run hello on a remote machine. Suppose we use a telnet client running on our local machine to connect to a telnet server on a remote machine. There is one local machine, there is one remote machine. Local machine is known as the client machine. Suppose I am using a machine, I am the local machine. I am using the local machine, that is known as the client. Suppose I am accessing my data from your point of view or from your computer. So your computer is known as the server and my computer is known as the client. Means in simple terms, from where all the operations are performed, that is known as the client, and from where all the data or all the material are fetched, that is known as the server. So local computer are used by the client and the server uses the different computer, that is a remote machine. This is the diagram. This says using telnet to run hello remotely over a network. First one is user types hello at the keyboard. So first point is user has typed the hello to the keyboard. Then client sends the hello string to the telnet server. Whenever or when the user finished the typing hello with the help of keyboard, the next step is of the client that sends hello string to telnet server. Then third point is server sends hello string to the shell, which runs the hello program and passes the output to the telnet server. Means first of all, user types the hello word, then client sends the hello word to the telnet server, then server sends hello string to the shell, which runs the hello program and passes the output to the telnet server. Then fourth point is telnet server sends hello word string to the client. Then at last client prints the hello word on display. So these are the 5 steps how telnet works. First of all, user writes the hello word, then client sends to the telnet server, server sends the hello to the shell, shell interprets the command and passes the result to the output or to the telnet server again. Then telnet server sends the data to the client and then client displays the data. So these are the multiple steps that is available when we are using the network to communicate with one system to the another system. This is the diagram. A network is another input-output device. This is the same CPU, this is PC, input-output bridge, main memory, expansion slots, there is a USB controller, graphic adapter, disk controller, all are same, but a new device is added that is known as the network adapter. Why we are attaching this device? So that multiple computers, when there is a scenario that multiple computers communicate or connect with each other. So this is a device, this is the adapter that is used in the computer to connect or to communicate with multiple computers. The best example which I gave you, suppose I want to give the printout or give the hard copy or give the print command and printer is not attached to my computer. So I have to share the printer. Sharing is only done if there is a network in the computer and network is performed by using the telnet command. So these are all terms are related. For example, if I want to print the hello, first of all user writes the hello word, then client sends the hello to the telnet server, then in turn telnet server sends to the shell which interprets the command and sends back the result to the telnet server, and then telnet server gives the result to the client, and then at last client displays the output. So there is a need for the network that is attached to the network adapter. Now let's see one by one. Returning to our Hello program, we could use the familiar Telnet application to run Hello on a remote machine. Suppose we use a Telnet client running on our local machine to connect to a Telnet server on a remote machine. After we log into the remote machine and run a shell, the remote shell is waiting to receive an input command. So this is the main task of the shell, to communicate with each other, to interpret the command and send back the result to the Telnet server. From this point, running the Hello program remotely involves the 5 basic steps as shown in the figure 50. After we type the hello string to the telnet client and hit the enter key, the client sends the string to the telnet server. So this is the second point. After the telnet server receives the string from the network, it passes to the remote shell program. Then the shell program runs the hello program and passes the output back to the telnet server. So server sends the output to the telnet server. Finally, the telnet server forwards the output string across the network to the telnet client, which prints the command on the local terminal. So these are the 5 steps that is available whenever we have to print or whenever we have to give the command, and if there are more than one computer, then we use the network system. This type of exchange between client and server is an example of network application. This is how we can use the network when there is a communication between computers from one part to the another part. Then there is next topic, that is important themes. Important themes means important terms. This concludes our initial one-line tool of systems. An important idea is to take away from the discussion is that a system is more than just a hardware. System is nothing a hardware. It's not a hardware, but it is a collection of hardware as well as a software. It is a collection of intertwined hardware and software, system software, that must cooperate in order to achieve the ultimate goal of running application program. The rest of this book will fill in some details about hardware and software, and it will show how, by knowing these details, you can write programs much faster, more reliable and more secure. Means if you are able to understand these concepts, so you are able to understand, or you are able to do the or make the code or write the code in a faster way, in a more reliable way, and in a secure way. To close out this chapter, means to finish this chapter, we highlight several important concepts that uses across all aspects of computer system. There are multiple themes, there are multiple terms available. First one is concurrency. Concurrency means more than one. In simple terms, more than one. So whenever we are using more than one activities at the same time, that is known as concurrency. This says throughout the history of digital computers, two demands have been constant forces driving improvement. We want them to do more and we want them to run faster. But both of these factors improves when the processor does more things at once. We use the term concurrency to refer to the general concept of a system with multiple simultaneous activities. As I told you, when there are more than one task, that is known as concurrency. So concurrency is a term of a concept of a system with multiple simultaneous activities. Multiple means more than one, and simultaneous means that are performed along with side by side. So multiple and simultaneous activities are performed side by side, and that is known as concurrency. And there is another term, that is parallelism, that refers to use of concurrency to make the system run faster. Means parallelism is helping in getting the concurrency control so that things are done better or things are doing better here at multiple points. Then next is said parallelism can be exploited at multiple levels of abstraction in a computer system. We highlight 3 levels, that is thread level concurrency, next is instruction level parallelism, Next is single instruction multiple data parallelism. That is SIMD parallelism. Then what next topic is importance of abstraction in computer system, means what is the importance, why we are using the abstraction in computer system. The use of abstraction is one of the important concepts in computer science. For example, one aspect of good programming practice is to formulate a single API, that is application programming interface, for a set of functions that allows the programmer to use the code without having to deal into its inner working. Means abstraction means getting the abstract figure or getting the layout or getting the background details or getting the detailed version without including background details. So abstraction is nothing but a part of the computer system to get the essential features only without getting the background details. So abstraction is one of the important tasks that is available in computer system that helps the programmer to do the task in a very easy way or to perform the task in a very easy way with the help of C programming, with the help of Java programming. So abstraction is basically used with multiple programming languages such as Java and C function prototype. This is the example of abstraction: virtual machine, processes, virtual memory. There is a files, main memory, primary memory. So then at last there is a summary. I read the summary line by line because this is one of the important summary. A computer system consists of hardware and system software that cooperates to run application program. So computer system is nothing but it consists of hardware and software that cooperates to run the application programs. Information inside the computer is represented as a group of bits. So whenever we store the information inside the computer, it is represented by a group of bits that are interpreted in different ways depending on the context. Programs are translated by other programs into different forms beginning with the ASCII code. As I told you, there is the ASCII test, that is American Standard Code for Information Interchange, and then translated by a compiler and linker into a binary executable file with the help of compilation system. Then next paragraph says processors reads and interpret binary instructions that are stored in main memory. As I told you, processor means CPU reads and interprets only the binary instructions that are stored in main memory. Then since computers spend most of their time in copying data between input-output devices, memory and CPU register, storage devices in a system are arranged in a hierarchy. So this means instead of moving or instead of jumping from one place to another, there is a new device, there is a new method that is known as the memory hierarchy, which we are using in a computer system. As I told you, memory hierarchy, there are multiple hierarchies, there are multiple memory ranging from L0 to L6. Next one says storage devices that are higher in hierarchy are faster. Means storage devices that are higher means that are at the top level are faster and more costly than those lower in the hierarchy. Means which is at the bottom is less costly and is less faster as compared to the top level hierarchy memory. Storage devices that are higher in the hierarchy serves as a cache for devices that are lower in the hierarchy. Means which are at the top of the hierarchy becomes the supervisor or becomes the guider for the lower level hierarchy. Means if a super level hierarchy needs some data, so it fetches the data from the lower level hierarchy. Then next one is programmer can optimize the performance of their C programs by understanding and exploiting the memory hierarchy. So whenever a programmer wants to write the C program, it must be implemented or it must be understandable by using the memory hierarchy. So as I told you, memory hierarchy is nothing but the hierarchy of the memory starting from L1 and ending with L6. There are multiple types of memory that I am using, that we are using, that a computer system is using when a C programming language or a Java programming language or any programming language is used in the C language. or is used in the computer system. Next is the operating system kernel. Serves as the intermediate between the application and the hardware. As I told you, operating system is nothing but acts as a mediator between operating system, between the application software and the hardware. Suppose I want to use any application software, so I want the hardware also. So that is done by the operating system to provide the gap or to provide the mediator between hardware and the user, means between hardware and computer programs. Then it provides three fundamental abstractions. It means operating system provides three fundamental abstractions, that is files, next one is virtual memory, next one is processes. Files are used for input-output devices. Suppose I want to store something, so that is done by the files, that is used for input-output devices. Then next one is the virtual memory, that is used for abstraction for both memory and the disk. Suppose I have a data that is not compatible or that is not fitted into the main memory. So that data must be going to another memory, and that another memory is known as the virtual memory. Means if there is no capacity in the memory, so that information which is not available, which is not covered in the main memory, is going to the virtual memory, and that is known as the virtual memory. Next one is your processes, means the third part or the third fundamental abstraction of operating system is processes. Processing is nothing but a programming execution. Suppose I am writing any program, I am performing any program, I am executing any program. So that is done by the using the processes. So processes is nothing but a programming execution. So whenever we write the program, that must be executed. So whenever a program is executed, that is known as the processing. So processes are abstraction for the processors, main memory and input-output devices. Next is finally, network provides way for computer system to communicate with one another. Means at last topic is our network. So network is nothing that but a method that provides when we are using more than one computer, so that computer can be communicated with one another and perform the task very easily, so that they must be converted into the one to the another. From the point of view, from the viewpoint of a particular system, the network is just another input-output device. So in computer system, everything acts as a network, or everything acts as the input-output devices. So that's all for chapter number 1. I think that's enough for today's session, because this is too hectic or too tough topics. So I think first chapter is sufficient for you to cover. Only first chapter. Please read the first chapter and please clear the doubts along side by side. Because if you have not cleared the doubt, then it's very too hectic or it's very too hodgepodge to collect all the doubt and then at last manage the doubt or ask the doubt. So it's my humble request to study both the lectures that contains first chapter and please clear the doubt. But before ending this session, for today's session, let's recall the whole unit, whole chapter which we have covered yesterday and in the today's class. So let's take a review of from the starting page. We have started with computer system, that is nothing but a collection of hardware and the software. And we have also termed what is C language, and also talked about some programming concept, that is simple a C programming code, that is hash include stdio.h. Hash means that is used for included, and include means include the header file, and the name of the header file is stdio.h. The full form of stdio.h is standard input output dot h. So this is nothing but the header file, and the header file is nothing but that contains multiple functions or library functions that we are using in the program. Suppose I am using printf in the program. This is the library function that is available in the standard input output. Suppose I am not using standard input output. So this gives an error because there is no header file and I am using the library function that is printf. So it's mandatory to give the header file if there is any library function which I am using. For example, suppose I am using any math function or any math function. So it's mandatory to give the header file that is #include math.h. So whenever we are using any library function, so it's mandatory to give the header files at the top of the C programming code. Next one is int main. Int main means we are opening the main page. We are opening the page that is int main. Then there is a curly braces. There is a printf statement. Printf is used for writing over the display or for displaying any line. This is printf hello world. Means this line prints the line that is hello world. There is a /n also that is used for jumping to the next line. Means whenever I am finishing with the hello world, then automatically cursor moves to the next line. This is the basic program for the C language. Then next is information. Information is nothing but a bit, and bits is nothing but a collection of zeros and ones. And when we combine multiple bits or 8 bits, that is known as the byte. So information is nothing but a collection of bits and a context. Context means a ASCII character or the ASCII code. ASCII code is American Standard Code for Information Interchange. And all these characters, that is ASCII characters, are stored in a separate file that is known as the text files. These are the multiple ASCII characters. Then we have talked about what is C language, that is developed by Dennis Ritchie at Bell Laboratory. These are the multiple features of C language. Then second point is programs are translated by other programs into different forms. Means one program is converted into another form, that is executable form or binary executable form. That is machine language program, executable object program, executable object file, and a binary disk file. So this means a compilation system converts into multiple forms like binary file, executable object file, executable binary file, or an executable object file. There are multiple phases in compilation system like preprocessor, compiler, assembler, and linker. These are the multiple phases. Then third topic is it pays to understand how compilation works. Means there are some benefits which is available when we are using the compilation system. These are the benefits available. Then fourth point is processors reads and interprets instructions stored in the memory. Then what is the hardware organization of the system? What is buses, input output devices, main memory, processor. Then how to run the hello program. There is also a figure that how we can run the hello program. Then how to load the executable from disk into the main memory. How to write the output from the memory to the display. Then fifth point is cache memory. Means what is the use of cache memory? When a computer system or when our program is jumping from one part or one place to the another place. So there is a need for the cache memory so that it must be stored, and whenever there is any requirement, we can fetch the data from the cache memory and displays the output and performs the operation. So there is a cache memory that is used for storing the data. This is a cache memory. Then sixth chapter is storage devices from a hierarchy. There is a next topic is storage devices from a hierarchy. There is a hierarchy of the memory, that is multiple parts of the memory, that is starting from L0 and ending with L6. So we are arranging the devices, or we are arranging the multiple disks into multiple levels of hierarchy, so that we can store the data at every point of time at every level of the memory. These are the hierarchy. L0 is registers, then L1 cache, L2 cache, L3 cache. There are three types of cache memory, that is L1, L2, L3. Then there is a main memory, there is a secondary memory, and there is a remote secondary storage. Then 7th point is the operating system manages the hardware. Means how the operating system manages the hardware, what is the use of operating system in the computer programming. The main two purpose of operating system is to protect the hardware from misuse and to provide the application with simple and uniform mechanisms. This is a layout of the operating system that acts as a mediator. This is the operating system which acts as a mediator between application program and the input-output devices. This is the abstraction that is provided by the operating system. Then we have also talked about what is the process in the operating system. These are the figure. This is the figure for processors. Then what is a thread? What is a virtual memory? Thread is nothing but when we are using the same process with multiple executions that are known as threads. Means one execution of process is known as thread, another execution is known as thread, and when we are combining multiple executions that are known as threads. Then another concept is virtual memory. Virtual memory is nothing but the add-on memory to the main memory. Suppose my data is not fitted into the main memory, so that is going into the virtual memory. This is a diagram for virtual memory. Then there is a concept of file. A file is nothing but a collection or the sequence of bytes that is used for storage purpose. Then how one system will communicate with another system with the help of the network. There is also a term known as the network in the computer programming, so that multiple computers can communicate with each other with the help of network. There is a new device that is attached known as network adapter network that is used for communicating from one part to another part. Then we have also talked about some important terms, that is what is concurrency, what is parallelism. Concurrency means more than one task at the same time. There are multiple levels of concurrency, that is thread level concurrency, instruction level concurrency, single instruction multiple data parallelism. Then what is the importance of abstraction in the computer system? That is showing only the important details and hiding the background details. Then we have talked what is the summary for this one. So that's all for today's session. If you have any doubts, then please text the doubt. I will answer you each and every doubt. And from tomorrow's class, we will start with second chapter, that is representing and manipulating the information. So that's all for today's session. And if you have any doubts, then please clear the doubt.